All right. Yep. So Stephen's asked me to present this today. This was a building we did. I think we designed it back in about 2016, 2017. It kind of got built by about 2021, and quite an interesting little project for various few reasons. So should be relatively quick. I should get through this in about 15, 20 minutes, and then we can have a bit of a chat about it. I have done this similar prezzo for Wood Solutions in the past and a couple others as well. So I always try and add a few new things in there for those who might have seen it in the past, but hopefully a lot of it's all kind of a bit interesting for you. So I'll just just go like that. Right. So where is it? For those based in Brisbane or those not based in Brisbane, Kangaroo Point is where it is. So it's obviously quite a prominent location in Brisbane, especially in the apartment industry. So, with being so close to the CBD, so close to the Gabba, that kind of thing, it's obviously got gonna sell pretty well. Although I might add, this was done in 2018, 2019, where the apartment industry in Brisbane actually wasn't really strong. It was kind of at the low point of it. So there was what you would get today for them was very different to what you would get back then. So it had its challenges. So the architect was GVG, or Gardner Vaughan Group, who are also the builder developer. They have their own in-house architects in collaboration with Hayes, Anderson, Lynch. Aurecon did the structural engineering, and the timber supply was local based, so Australian based from XLAM, did the CLT, and Hein did all the glulam. So you can just see at the bottom right picture, or the right picture there, some fairly good views of the city. Hence its prominent location. That's just a quick site landscaping plan of the site. So quite a confined site, very skinny, with really only access from Lambert Street on the right-hand side, boxed in by heritage buildings to the north, little heritage Queenslander cottages, and then a hotel to the south. So pretty boxed in site, very skinny. Kind of got to maximise the space we can on it. Couple of Google views. I always like doing the Google views because it looks like what the site was before it was built. So that was what on the left picture, you can kind of see the hotel in the background, which is that taller one on the left. The little two-story brick building was the existing building that was there. The existing apartment blocks that were there, which were your classic 70s style apartment block in the area. And then to the right of that is those Bay of Heritage listed little Queenslanders. Then obviously on the right shows the new building that went in. So a big change to the site and to the area. That's a good kind of a representation of what was trying to be achieved. Another good picture there. From the north, that is. So you can see those heritage buildings at the front, which are the little timber Queenslanders. So it kind of speaks to the language of for timber, but quite a good facade that you do see. It's one of the first tall buildings you see when you drive across the Story Bridge heading towards Wollongabba. So it coming out of the city. So it does it is a prominent location. Why timber? So this is something every timber building we've ever done, you do have to ask this why timber. You have to have a strong why timber. Some are stronger than others. So speed of construction and site constraints were obviously one for this building that we're in, that was part of it. Aesthetics. So I'll talk about a little bit about aesthetics. This is a little bit different in doing it in an apartment building. All the office buildings and education buildings you really want to show off the timber. Not the case effectively in an apartment building. So I'll talk about that. Obviously, sustainability is the main byproduct of using timber. So that's about it. But really, this whole project and this reason for using timber on this site was the weight. Okay, so weight was pretty much king in this instance, and the fact that we use the timber to save on weight, which I'll talk about now. So the top left image that you see there is the yellow is the site, north is kind of to the right. The edge of the site, the back edge of the site, all sits directly over the top of the Clem 7 tunnel that runs underneath Brisbane. Okay, and that image on the right there, top right, actually shows roughly how close that tunnel is actually to the basement that we ended up with. So it's fairly close, and that's partly because the Clem 7 tunnel is actually on the rise up at that stage and getting close to its exit. What we needed to do as part of the development application, and this is normal on any building that's over the top of the tunnels, in this is as part of the development application, you have to do a tunnel assessment on this. Normal 2-3 story buildings get away with it pretty easily, but obviously a 10-story building is a bit different, and effectively there's a pressure that you can deal with at the top of the crown of the tunnel, which is 50 kPa, that you have to design to. Okay. So that means you design your foundations up the top. This is all on rock, so it's really, really strong rock, so you can get away with pad footings and shallow foundations, which have a high bearing capacity. You've got to be able to justify that it spreads out to 50 kPa once it gets to just above the tunnel. So we're pretty lucky in Aurecon that we've got tunnel engineers and really good tunnel engineers do this all the time. So we were able to work with them and with GBG as a partner to kind of come up with an arrangement to make sure we hit that 50 kPa above the tunnel as part of the development application. You've got to do that. So, we would give them loads, which is down in the bottom left there. So kind of all those highlighted areas gives you the main loads for the building. And, some of the analysis they do, and they do some 3D, pretty cool 3D stuff, is on the right there, where they look at the pressure bulbs that occur and how the pressure spreads out as it gets towards the tunnel. So when we were doing all that, part of the reason we did timber there is we were able to work in collaboration with the tunnel people to actually come up with what's going to be the best outcome for this site. Okay. So we tested a few solutions, and I've done a couple of crude sketches there. Effectively, a traditional concrete, if you're going to do the stock standard concrete design on this, you might get away with 6 or 7 levels of apartments, okay, and actually only one basement. So the amount of basement actually comes into it as well, because you're taking soil off the tunnel. So the depth of basement actually comes into this whole assessment. Then we looked at a kind of a steel concrete hybrid to save on some of the weight. So that's where we moved to. And lo and behold, we were able to kind of justify an extra basement level and an extra 1, maybe 2 stories on that. And then we looked at a bit of a timber concrete hybrid, and we were able to get it up to 10 stories of apartments. Okay. And like I mentioned at the start, at the time, the apartment industry, or the sales of apartments in Brisbane wasn't really strong. The first 2 that you see on the left there, the concrete and the steel options, wouldn't have made this a viable development for GVG, right? So in other words, to buy the block of land, to demolish what was there, to build the cost of building of all this, and then to sell back the apartments. At the time, there wasn't enough apartments. With those 2 options, there wasn't enough apartments to actually make it a viable development. However, with the timber option and being able to add those extra couple of levels of apartments, especially up the top where you're going to get all the views of the city and get the more expensive apartments, it made it a viable development. Okay, so without using timber to save on the weight on this project, this wouldn't have been a project. All right, so timber is the hero on this one as a structural material. So there's a bit of a snapshot of the Revit model on it. So what have we got? We've got a concrete base, and it's concrete up to basically a level 1, which is our big transfer floor. That's pretty all traditional concrete construction. Concrete walls, concrete basement, slabs, concrete level 1. From there up, it's effectively all timber except for the core. So the core is a concrete core. The reason it is a concrete core again is because we didn't have any opportunity to brace the outside of this building. Obviously, in an apartment building, if you go and brace it, you'll ruin everyone's beautiful view of the city. So we had to have an offset core to one side, which obviously creates a whole heap of eccentricities. The easiest way to deal with that was to do a concrete core. And the developer builder, having done plenty of them in the past, was happy with that. It also solved obviously the fire rating issue that you need in your stairs and your core and that. So that was the decision that was made there. But the floors and the rest of the structure out from that are timber. Next one, there's a couple of sections through the building. So you can see that the long section on the left, and the kind of the difference in levels through there. On the right is the skinny section. So you can see it is a very long, skinny type building, which has its challenges, and the couple of levels of basement at the bottom. Oops. So there's a couple of plans. 2 plans. So I've written timber mindset there. So what we found is that what you need to do is you actually need to start from scratch, and you need to we work really closely with the architects to come up with a scheme of apartments that was flexible, because don't forget they haven't sold all of these yet. So there's often changes that are needed and required by the sales team when you're building off the plan. But also works to timber. Okay, so that meant the traditional concrete styles that you might do, where you might do transfer floors every few floors to change up the apartments, just wasn't going to work with timber. So we had to come up with this scheme that was flexible. So what we ended up with was basically a 2-level system that covered all of the 10 floors, where the only difference that we had was that blue highlighted wall. That was it between the 2 levels. And what that meant was, we could have bigger bedrooms, penthouse style apartments up the top, and smaller ones down the bottom. Timber schemes. So I've written a few steps there. So this is the general timber floor layout, where typically what you'll see is we've got load bearing walls, so CLT walls. We have some glulam beams in some of the bigger spans through there where we couldn't get walls in. Apartments kind of lend themselves to walls for supports, because obviously you've got plenty of party walls between buildings, between apartments. And then what we also had is we then have the CLT, and we were able to kind of maximize the length of the CLT across there. So the biggest one that we had, and we worked with XLAM on this, was about a 13 metre. It's at its widest width was about 13 or 14 metres. It meant you could basically cover the whole building with one plank, which made it really, really quick to install. So that was key, and that was all part of setting it up and discussions with XLAM at the start. So input from the manufacturer and supplier was absolutely key in this. Acoustics in residential were a massive part of this, so far as to that in some instances, especially on the higher levels, the walls were better to be thicker from an acoustic perspective. So don't discount that. Non-load bearing walls for materials. So you might see, if my little pointer works, and hopefully everybody can see this, up here you'll see that the kind of wall stopped about there. So we worked out, and we did a lot of analysis on this, that wall only needed to be about that length from a structural perspective. It didn't need to go all the way. So we with GVG actually tested, well, would it be easier just to run that all CLT, or actually is it cheaper and better not to run that all as CLT, as in don't use CLT just for the fact it makes it easier. And they did a lot of testing, and it was actually easier just to do that bit in a light partition type wall. So things like that can get tested. You know, sometimes I think we jump in a bit too much and might use more timber than what's required. That was one thing. Wet areas, so all those little green hatches are bathrooms. So dealing with bathrooms and set downs in a fairly flat CLT slab. Keep in mind these were pretty premium apartments, so the anticipation from buyers is that it will all be a seamless flat, as in you will have a set down for a bathroom for all your tiling and that kind of thing. You won't have a threshold step up. So coming up with a floor finish across this whole floor that could incorporate them. Fire engineer, obviously that's key. We had to work with the fire engineer from day dot to get this right, and it's a coordinated design. It's not that they tell you something and you go do it. You need to constantly be going back and forwards to come to a viable solution. Penetrations. So penetrations, when you've got an exposed timber solution, it's obviously better to have the penetrations done in the shop because you get a much better finish on that. Doesn't provide a huge amount of flexibility on site, and like I said earlier, not all these apartments were sold, and sales team have to be able to make changes on the fly. So we kind of came up with a strategy where there was zones, dedicated zones where they could penetrate. So it didn't mean it was done in the shop. It just meant that come site time, if they had to go and cut a few extra holes, here's where they could do it very easily and quickly. So so there's a couple of shots during site. So the one on the left shows the core kind of in the background, concrete core, and then all the CLT walls. You can see it is quite a confined site. One on the right showing some of the CLT getting installed. Close that down. The roof. So the roof's a little bit different to what you would normally do too. So it is a timber framed roof with a little bit of steelwork in some areas where we couldn't get the timber to work. A couple of notes about that. So interestingly, the steel roofers that put this together were nervous at first, and then actually said it went together better than any steel roof that they've ever put together. So interesting in terms of a tolerance point of view, that they were actually happier with the timber than they had with any of the steel roof that they'd ever done. Note on that, we went with kind of a braced style roof, cross-braced style roof. Connections of these became very tricky. Probably something we'd do differently if we had a time again. And getting tie downs to kind of line up with the structure below was also tricky, given this is the penthouse. It has different wall layouts to the floors below. The other one, the image on the right, bottom right there as well, is an interesting one. It's just to do with the waterproofing solution. So there are some external balcony areas up there that do have a CLT deck, and there was a lot of work that went into the waterproofing system that's there, and grout buildups and then false floors on top of that as well. So one of the key, I guess I didn't want to do too much on the structural, too many technical stuff, but one of the key things that we came across from a structural perspective is, so you've got a 10-story concrete core that's not going to shorten or reduce in height too much, versus this timber structure that's out from that concrete core that is going to shorten, and it'll shorten for two reasons. One is just pure load on it over time squishing, and the other one is moisture. So as the moisture content, as it becomes all enclosed and the moisture content comes down, everything's going to shorten a little bit. And so we looked at obviously the two different types of framing to do, the platform versus balloon framing. The platform framing, would work okay, obviously, except now you get a lot more shortening when you're going perpendicular to the grain through those slab zones, but it's also a lot easier to build than your balloon framing, which is on the right. So there was a bit of a trade-off where there were areas where we could do platform framing versus balloon framing, that the GVG wanted to do that, right, because it was just going to be quicker to build. And what we had to do is basically, work out all the stresses in each of the walls, work out where we could do the platform framing, where we could do the balloon framing, and account for things like moisture change and that kind of scenario. We were lucky that almost just after we'd started the design on this, XLAM had actually done some testing on strengthening cores through platform framing like that. So we were able to tap into that experimentation data that they had done. And what we came up with, which is on the right there, that image on the right, you can kind of see is there's a wall under where you see those little concrete blocks. There's going to be a wall over. And so it was actually a matter of cutting little holes into the CLT, into the floor, that would be filled with concrete, prior to the timber wall going over. And what it meant was those little concrete blocks were there to help with that axial shortening. So they locally through the slab, they would take all the vertical load, right? And it was actually really good because it comes to site, the CLT comes to site already with those little blocks cut out, and they already had concreters on site because they were doing the core. So it was just a matter of, a few buckets of concrete to fill all those little cores. So it actually worked quite good, and it meant that timing wise, it was still really quick to do. And then obviously there's how do you tie it into the core, because now you've got this movement zone. And effectively we came up with a few smarts in the preliminary design where you can, that top left image that you see there is all about the walls that call it the hallway walls, where you walk out of the lift and you'll see that wall, which was an exposed CLT wall, would actually be able to take all the CLT load from above, the floor load from above, and we didn't have to rely on a vertical load support to the concrete core, right? So it was just tied in from a lateral perspective, and it meant that there was a threshold that we could build up, given it's not a big distance between those 2 points. As you can see there, it's a pretty skinny hallway. So you could actually, over time, if that CLT side was to drop a little bit more than the core, you wouldn't notice it, right? So it was almost like a little pivot joint detail that we did there. Couple of environmental benefits that I threw in there. Again, this project wasn't driven from an environmental perspective. It was more a byproduct of that. So CO2 emissions were, something like 3,700 tonne by using timber versus your traditional methods, and that's set. I always like comparing it. It's about 700 petrol cars off the road for the year. It's a Enviro development accredited as well, so that's obviously they're all about purchasers recognizing, selecting more environmentally sustainable developments. So that's a really positive outcome for it as well. Costs, so costs are a big one. So I don't have the exact costs on it. Obviously that's a GVG thing. I do know it was more expensive than if they were to build a stock standard traditional construction. But what we've got to understand here is it wouldn't have been a project if it was a stock standard construction. It wouldn't have been a development in the first place. Okay, so there's in terms of comparing it to those costs of the fact that, and don't forget this was 6-7 years ago, that where there was probably a little less supply of timber. Those costs were already taken into account to the fact to get this to be a viable development anyway. And the other one to add is actually by the time that the building had gone up or started to go up, there was a fair bit of media about it, and locally as well, real estate agents were really selling it, and actually they were using that as a sales pitch, that this was going to be Australia's tallest timber residential building, and you could be in a very environmental sustainable building, and that actually drove the sales. So much so that that they were selling these units quicker than what was anticipated, and quicker than what neighbouring developments were doing as well, because it's so that's a hard thing to put a price on as well.
Yeah, so we really get started.
There's a couple of images on the right during construction. On the left, when it's kind of finished, you'll see a lot of it gets covered up. So a lot of the timber got covered up. Couple of reasons. So from a fire perspective, obviously that helps, because there is fire rated plasterboard in behind that, and that was part of the fire engineering solution. But also these are units. Over time, you know, you change sales, you change hands, that they could have renters in some of these, you know, people go and paint units and change things to how they want. They really didn't want, you know, the timber exposed inside the units that would get damaged by that in the future. So it's a little bit of a difference in what we used to in doing, you know, education buildings and office buildings where it's all exposed. There's just a couple of other images. So that's it finished on the left. We did expose timber where we could. So for example, all of the balcony soffits that you see there are all the exposed CLT. Okay. So again, you know, there was no, we were able to work with a fire engineer and work out that we can actually get, you know, do a char calculation, work out that, you know, we didn't need the fire rating out there, and then actually expose those. And, you know, they're not in direct wetting. They're kind of the soffits, so that they do get a bit humid, but that's kind of the, yeah. And there is a pool, but it's on it's not on timber, it's on level 1, so that's on a concrete. That's it.